back for the fifth video. In this and the next video, we'll be creating sort of a scenario in which we'll be optimizing a canopy or a roof structure on top of a street. So this is our street, imaginary street, and we are going to we are going to create roofs between these three buildings. So let me put these B reps in. Set multiple B reps for the left hand side, set multiple B reps for the right hand side. So one thing that we want to do first is to prepare this file, right? So let's say each curve or each building can have the length of its total heights 70% as untouched, or let's say non-constructible. So we can go and let's say this is 100 meters. It's not, but it's 100 meters. We can go down only 30 meters. Okay, so let's create something as such. So what we are going to do to do that, we have to extract these curves, right? To do so, why don't we deconstruct these B reps, and select the like top faces first. Let's grab a list item. I mean, this might be a bit, yeah, I was suspecting this. This is a lucky selection for these three, but I want to make sure that these are the correct ones. So what I'll be doing, I'll be sorting these curves, sorting these faces based on the centroids, their centroids Z value. So let's sort them all in based on these values and based on these values. So what we are going to do now is when we put a list item, we'll have the surfaces on the bottom, right? So if I go and select the -1 index, it's going to give me this. And then if I deconstruct this B rep as well, deconstruct this, or you can explode this lines as well. And if I now sort the edges based on their midpoints x coordinate point on curve, and deconstruct its edges, right, and sort the edges after I deconstruct this based on their x values. So if I grab an item here, and what I'll see is, you see this is the one, but if I put -1 here, then I can have my lines over here. So this is how we prepare this first file. Okay, and I'll be doing the same thing for the below, but this time, since I am looking for the other edge, I'll be putting nothing here, or I can put 0 here, because these are the edges that I want to create the links in between, right? So each has one curve. So as I said at the beginning, so one thing that I am just trying to create sort of a like playing ground for my roof structures, right? For my boundaries. So what I can do here is to say, okay, let's get the very first one. So the height of this line, or the Z coordinate of this point, is here, but let's get the midpoint of this again to have the Z value. We'll be doing the same thing for all of them, right? Sorry, deconstruct this and we'll grab their Z values, right? We'll grab this Z value. This is important. Why? Because as I said, I can go only 30% down from its top location. So what I'll say is, if I say move these to these points, this is a just representation of it, right? what I would say is multiply this by 0.3, right? And on Z direction, negative. So it's a bit fast now. I'm sorry for that. So let me grab some space here. So what I am trying to have is I want to have Z values like 30% and move that into this area. You see now they are going all 30% down and based on their values. Or you can say, you know what, like I don't want to do this, I want to do it other way around. Or you can connect this into another variable such as the building height and so on and so forth. But that's pretty much how we are trying to have this. All right, as I said, based on this Z component, you can just remap these values and then say, okay, higher one goes below, larger one goes down, etc., etc. That's completely up to you. Are we done here? Actually, no, because what we want to do is we want to grab these end and start and end points and move these start and end points, right? Because we have start, we have end points. So we are going to move these ones, start points and the end points. And then I'll create a line in between these two. And those lines actually will give me a space. Oops, start and end. This point and this point, right? This point and this point. This is my line that I cannot go down. But if I grab the points, like end point, start point, end point here, start point and end point there, start point and end point. Or the other formula can be, rather than doing this, if I divide these curves, if I divide them with 1, I think, would that be helpful? Let's check. Yeah. So I have these 2 points. So what I'll be doing, instead of using these two, I'll take these points and push them down. And you see, like this has 2 points now, this has 2 points now. And if I create lines in between these, right, like these 2 points. So if I create line, these are my line. This is my starting line, this is my ending line. You see, now I can play around with this, right? Because the first point that I'm having here can be, or like what I can do here is to have, since I have 6 different lines, what I can do is I can determine each line's segment, right? Each line segment, so that I can have 1 point here, 1 point somewhere here, 1 point here, 1 point somewhere here, and so on and so forth. So if I evaluate this curve, let's see if I am hitting what I'm looking for. So let's reparameterize this 0.35. We put it here. So what we have achieved here is to have these 2 points first, and then these 2 points will have, let's say, another one. So this other one, you see, it's changing this one, but they are all same here, right? So this is something that we don't really want to have. So we want to control this with, like, let's say for each one we want to have 1 slider, for the second one we want to have 1 slider, and so on and so forth. And that would be the subject of our second and last video of this, and then we'll switch to how we can optimize this canopies or roof structures.